Namaste, and a very warm welcome to all my amazing Java learners. Today, we are embarking on a truly exciting journey, building a simple blockchain right here in Java. You might have heard about blockchain in the news, especially with cryptocurrencies like Bitcoin. It is a revolutionary technology, and understanding its core principles is incredibly empowering. In this 5-minute whiteboard tutorial, we will demystify blockchain, breaking down its fundamental components. We will learn about blocks, how they are linked using cryptographic hashing, and how to maintain the integrity of our chain. By the end of this video, you will have a foundational understanding and a working simple blockchain implementation in Java. So, grab your virtual pens and paper, and let us dive in. Alright, my friends, let us start with the very heart of any blockchain, the block. Imagine a block as a digital page in a ledger. Each block contains several crucial pieces of information. First, it has its own unique data, which could be transactions, messages, or anything you want to store. Then, it has a timestamp, recording exactly when it was created. Most importantly, it stores the hash of the previous block, creating that crucial link in our chain. And finally, it has its own unique hash, calculated from all its contents. This hash acts like a digital fingerprint. If even a single character in the block's data changes, its hash will completely change. For our Java implementation, we will create a block class with these fields: data, timestamp, previous hash, and current hash. This class will be the blueprint for every block in our chain. It is simple yet foundational. Now, let us talk about the magic behind blockchain's security: hashing. Hashing is a process that takes an input, like our block's data, and returns a fixed-size string of characters, called a hash. We use cryptographic hash functions, like SHA-256, which are one-way functions, meaning it is easy to compute the hash from the input, but virtually impossible to reverse engineer the input from the hash. A tiny change in the input data results in a drastically different hash. This property is what ensures immutability. Each block's current hash is calculated using its data, timestamp, and the previous hash. If someone tries to tamper with an old block's data, its current hash will change, breaking the link to the next block, and immediately revealing the alteration. We will implement a calculate hash method within our block class, utilizing Java's MessageDigest class to generate these secure SHA-256 hashes. This is where the security of our blockchain truly shines. Excellent. We have our block class, and we understand hashing. Now, it is time to put it all together and build our blockchain class. This class will essentially be an array list of block objects. We will start by creating a genesis block, the very first block in our chain, which has no previous hash. Then, we will implement methods to add block to our chain. When adding a new block, we must ensure its previous hash correctly points to the current hash of the last block in the chain. The new block's own hash is then calculated. Most critically, we will implement an isInvalid method. This method will iterate through our entire blockchain, verifying two things for every block. First, that its current hash is indeed correctly calculated based on its own data, and second, that its previous hash truly matches the current hash of the block before it. This validation is what makes our blockchain robust and trustworthy. As you build your own blockchain, it is common to encounter a few tricky spots. One common mistake is incorrectly calculating the hash. Remember, the hash of a block depends on all its data, including the previous block's hash. If you miss any component, your hash will be wrong and your chain will be invalid. Always ensure your calculate hash method includes the data, timestamp, and the previous hash. Another pitfall is forgetting to validate the chain after adding blocks or making modifications. The isChainValid method is not just for show, it is the backbone of your blockchain's integrity. Always run this check to confirm that your chain has not been tampered with. Finally, make sure your data types are consistent, especially with string conversions for hashing. These small details ensure your blockchain operates securely and correctly. And there you have it, my aspiring Java developers. We have successfully built a simple, yet functional, blockchain from scratch in Java. We started by understanding the fundamental structure of a block, then explored the cryptographic magic of hashing for immutability, and finally chained everything together in our blockchain class, complete with validation. You have learned how to create a linked list of secure data, a decentralized ledger in its simplest form. The key takeaways are the interconnectedness of blocks via hashes, the power of cryptographic hashing for security, and the importance of chain validation. I encourage you to experiment further, add more features like transactions or proof of work. Practice makes perfect. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java tutorials. Keep coding, keep learning, and I will see you in the next video. Jai Hind.